Hi everybody, this is Mr. Ritter, and we would like to use our graphing calculators to generate for us a quadratic function based upon a table of values. And for those of you who are doing an experiment with a rocket or a catapult, a trebuchet, those kind of things, a projectile in motion, this video definitely applies to you. Or if you have a table of values, you can generate it. But anyway, these folks here, I got this off the internet. It's pretty nice. I don't know who generated it. I think it was NCTM, so credit should go to them. But anyway, this thing here is a catapult. They have this ball, this styrofoam ball that they use, set at 0, 0. And what they did was they launched this thing several times, um, several times, and they found a total distance. Their distance just happened to be 12 inches. Fancy that. But anyway, yours probably won't work out so nice. So what you want to do is do like an average distance. And so you would put your projectile, the ball, whatever it was, if you were using a trebuchet, you'd have to um, uh, put it appropriately. If you're using a catapult, put it appropriately. If you're using a rocket, set it appropriately. Launch those things, and then see where they land. Total number of trials divided. So you add up the total number of trials, divide it by the number of trials that you did, and that will give you your average. In this case, they did several trials, found out to be the total distance to be 12 inches. What they did with that is that they hypothesized that the axis of symmetry would be half of the total distance. So this became 6 inches. So if there was 12 inches, 6 inches is half. And so then what they did was they marked these distances on the floor with some tape, or some method of marking, slips of paper on the floor, whatever. So 3 inches, 6 inches, 9 inches. Then what they did is they took some painter's tape and measured from the floor up along the wall here, up the wall. They measured several distances, and these distances will depend on how high you go. So you want nice even distances, and so what they did was that let's say that the first shot went here, the second shot they went here, and the third shot they went up this high. They measured each of these distances, and then put them into a nice table. So here was our first trial. Let's just say hypothetically it went up 8 inches. The second time it went up 10, and then the third time it went up 12 inches. All right? So what we need to do is find the average for this group right here. And so the average for the group is 8 plus 10 plus 12, and that equals 30. We have 3 trials, so we want to divide the total divided by 3, and that is equal to 10. So we put 10 as the group average. You would do this, you take measurements at each of these positions, at wherever half was for you, and then again at a third spot that was a quarter of the way, 3/4 of the way distance. So they had 4 pieces of tape, right? 4 things here: 0, 3, 6, and 9. This was quarter of the distance, this was half of the distance, and this is 3/4 of the distance. So that's kind of a nice way to set up your experiment. And then so they took measurements, and I just made up an arbitrary number here. I just kind of guesstimated and said, well, the average heights at 6 inches out from the trebuchet, rocket, or whatever catapult was 32 inches. The height was 32 inches. The height here, the average height here, was 12 inches. So then these up here, x equals 0, 3, those are my independent value, the values of x. The group average heights are the dependent value, or y. So now we want to enter this information into the calculator. And so L1 will represent x, and L2 will represent y in the calculator. So let's get our calculator. We need this guy And second quit. I'm going to clear. I was messing around earlier. Alright, and let's see here. Get the big screen. So how do we do this? Well, first of all, we need to turn it on. It's always a good place to start. And then we want to go to this button here, Stat. So I'm going to hit the Stat button. And now I want to edit. So it's already positioned there at Edit at number 1. So I'm going to hit Enter. Oops, we got some data in there. Well, if you have data in there, you want to up arrow. And notice L1 is highlighted now. Okay. Now I want to press the Clear button. Okay. It cleared all the values. And now I want to arrow down. And boom, it's gone. Very nice. Alright, L1 represents our X, so I want to type in all the values into this table editor that represent X. So here's 0, and I'm going to hit Enter. 3, Enter. 6, Enter. 9, Enter. Alright, we've got our data in for L1. Let's right arrow over to L2. And L2's values are going to be 0, Enter. 10, 32, and 12. Alright. Now I want to second quit out of this table editor. So I'm quitting out of that, second quit. And now I want to go back to Stat, okay, and I want to do a calculation. So I'm going to go here. Now, if you press Enter right away, you're gonna get the wrong stuff. You'll just generate a one variable statistics test, and we don't want to do that. What we'd like to do is to generate a quadratic regression. So you can either hit 5 or arrow down to 5. Hit 5, hit Enter. Okay, that gives us quadratic regression. Now if we hit Enter right away, again a second time, it'll generate the quadratic regression for us. And from here, notice that we have the standard form, ax squared plus bx plus c, and these numbers here correlate to what's out in front, these coefficients and the constant here. And we can, round these numbers down to something that's palatable to work our formulas with to solve by hand the axis of symmetry, the zeros, the maximum, minimum, and the vertex. Okay, we're not going to have a minimum in this case. We're going to have a max. But we want to be more efficient. So we want to be able to check our work as well, right? So let's clear this. Let's go back to Stat. I want to go back to Calc. Okay, back down to quadratic regression. So this time I'm going to press 5. All right. Now we want to pause here, and we want to go to vars. And then we want to arrow over to y-vars. All right. We want to deal with a function because we're generating a function. So I want to hit Enter. And then I want to store this thing in the Y editor. I want to store what the calculator generates for our quadratic function and store that in Y1 so we can graph it. So I'm going to hit Enter. Alright, so your calculator should look like this. If it doesn't, you need to go back up and try again. Okay, so quadratic regression Y1. Now I'm going to hit Enter. And there we go. It generated the same numbers, that's fine. But now, however, it has put the function into Y1. Well, this is great. Now we can graph it. Beautiful. Now, I was messing around earlier, and a similar graph has similar numbers. So what I would like to do is to show you what yours probably look like. Zoom 6. I'm going to go back to the standard window. So yours probably look like this when you hit graph. And so we need a way to view this. This window is a 10 by 10 window. And so a 10 by 10 by 10 actually, or 4 10s, there we go. Window size, and so we want to adjust the window size to see our parabola. So I'm going here to x min. I really don't care about the negative side of this function, so I'm going to hit 0 here. The max, the x max, is the largest value of our independent value, which in our case is 9. But we know that in our example that this thing went to 12, so I want to go a little bit bigger, okay? I'm going to go way bigger. I'm going to say 20 in here. Okay? That's larger than my larger than the greatest value I have in my table, the data that I took. And so the scale is going to be fine. The y-min, we really don't care about the negative side of this function, so I'm going to hit 0 there. And the max. Now the max, here we have 32. Down here we've got 32 as our largest number. So I want to adjust this y max to be larger than this number. So I'm going to hit 40 here. It's barking at me. Why are you barking at me? Oh, okay. We got to be on it. All right. It's got to be selected. There we go. 40. So that should do it, I think. I think we should get a nice representation. I'm going to hit enter now. Or actually, I'm going to hit graph. Okay. And there it is. In all its beautiful glory. So, this will allow you to check your answers as you know how to do this other stuff. It's in second calc. The value corresponds to the y-intercept. The 0 represents the x-intercepts. The minimum represents the vertex when it opens up, and the maximum, of course, when it opens downward. And so this will give us our axis of symmetry and, of course, our max and min, respectively. So I hope that helps, and any questions, please email or call, or we'll see you in class. Good luck on your projects.